Okay, lecture 4. We're going to do more with epsilon and delta today. Okay, and I'm going to prove to you that the limit of 3x plus 2 as x approaches 4 equals 14. Now, look at that statement. Do you agree that the limit of 3x plus 2 as x approaches 4 is 14? Because that's important. If you're going to try to prove something, it's very useful to believe it in the first place. Okay? As x approaches 4, 3x will approach 12, and 3x plus 2 will approach 14. Okay? We're going to prove this using the definition of limit. Okay, so do you remember what that means from the last lecture? We have to show that this is true. We need to show that for any epsilon greater than 0, there exists some delta greater than 0 such that if x is in the domain of our function, so what's the domain of our function? The function is 3x plus 2, right? What's the domain? All real numbers. So this is a shorthand way of saying x is in the set of real numbers, okay? And if the distance between x and 4 is between 0 and delta, then the distance between f of x and 14 will be less than epsilon. Okay? That's what we discussed in lecture 3, that's what it means to say that the limit of 3x plus 2 as x approaches 4 equals 14. Okay? So, I'm going to do that for you right now. Okay? Let's start out like this. So here, let me write this. We want to show that. Okay? So let's show that. Let epsilon be bigger than 0. It can be any number bigger than 0. People usually think of epsilon as being a tiny, tiny number, but it doesn't have to be. It can be huge. Okay? It can be any number bigger than 0. Okay? Let's say, suppose delta equals epsilon over 3. Would that be bigger than 0? Sure, if epsilon is bigger than 0, then epsilon over 3 is bigger than 0, right? Okay, so now watch this. Then for all x in the real numbers, comma, if the distance between x and 4 is between 0 and delta, then the distance between f of x and 14 will be what? Let's work it out. I mean, you know what I'm trying to get to, right? I'm trying to get will be less than epsilon. That's what I'm trying to get to. But the point is I have to show that. I can't just say it. I have to show it. Okay? So how am I going to show that? Well, let's simplify what we have here. Okay, the absolute value of 3x plus 2 minus 14 is equal to the absolute value of what? Wouldn't that be 3x minus 12? And can't I factor a 3 out of there, and I would get 3 times the absolute value of x minus 4? And if, look what it says here, if the absolute value of x minus 4 is less than delta, then 3 times the absolute value of x minus 4 would be less than 3 times delta. What did I say delta is for me? It just happened. It's epsilon over 3. And what's 3 times epsilon over 3? It's epsilon. Okay? So, for any epsilon greater than 0, there exists a delta that would be greater than 0, because I'm making delta be epsilon over 3, and that would be greater than 0. Okay? And then I can say, if x is a real number and the distance between x and 4 is between 0 and delta, then the distance between f of x and 14 is less than delta. Oh, sorry, epsilon. Okay? So what I've done is this. Given any epsilon greater than 0, I have found the delta that I would need. You see what I'm saying? So that, and I'm going to show you in a minute how you go about finding that delta. So what I'm saying here is that if I were to look at the graph of this function, oh, I didn't mean to do that in green. 1 second here. Okay, so let's say here's our function, 3x plus 2. Okay. And what I have done is this. Let's say there's 4. Okay, and there's 12. Oh, sorry, that's not the right number. I mean 14. So if someone comes along here and they choose a margin of error called epsilon, what I have found is I have found how close does x need to be to 4 in order for f of x to be in this range here. I have found out that if x is in this range, then f of x will be in this range. And how wide is that range? I figured out that that range right there is 1/3 as big as this. Epsilon over 3 on each side of the number 4. Okay? Now I want to show you, how did I come up with that epsilon over 3 as my delta? That's your delta right there. How did I come up with that? Well, I'll show you. I did some scratch work. Okay? And what I did was, I started by writing down what I want to happen, and I worked my way backwards to find out what I need to start with. Okay, so let me show you how to do that. I'll do that right over in this space over here. Okay, we want the distance between f of x and 14 to be less than epsilon. That's what we want. And I'm going to show you how to work my way backwards to get to what do I need to start with. Okay, and the key is, what do I get to control? I get to control this. I get to make the absolute value of x minus 4 as small as I want. So my goal is to work backwards until I can get the absolute value of x minus 4 is less than something. And whatever that something is, that's going to be my delta. Okay, so let's just work our way backwards. Let's go back up to the top of that. Just remember that this is our target. We're going to try to get to that, the absolute value of x minus 4. Okay? All right, so let's go back up to the top. So we're starting with our goal, which is the absolute value of f of x minus 14 being less than epsilon. Let's write in there what f of x is. It's 3x plus 2. Okay, let's simplify that. That would be the absolute value of 3x minus 12. So f of x minus 14 less than epsilon is the same thing as saying 3x minus 12 is less than epsilon. Okay, now remember, I'm trying to get to the absolute value of x minus 4, and what I have right now is the absolute value of 3x minus 12. And I noticed that, hey, if I factor a 3 out of there, then it would say 3 times the absolute value of x minus 4 is less than epsilon. And now I just divide both sides by 3, and it gives me my delta that I was trying to find. I just found it. There's the delta. It's epsilon over 3. And that's why I wrote that here. Okay? So that proves that the limit of 3x plus 12 as x approaches 4 equals 14. Okay, now let me show you another one. Let's do a second example. This time, let's prove that the limit of x squared minus 4x as x approaches 2 equals, what do you think the limit equals? If you had to just use your intuition, think about it. You have x squared minus 4x, and as x approaches 2, wouldn't that approach 2 squared minus 8, which would be 4 minus 8? What is that? It's negative 4, right? Now let's actually prove that. Okay, so if you had this function which is a parabola, kind of looks like this. Let me graph it real quick here. Oops. I don't know why that's moving around. Just a second. There we go. Okay, so it's a parabola that looks like this basically. Crosses the x-axis at 0 and again at 4. Okay, there's a vertex right here at 2, negative 4. Okay, so what I'm saying is this. somebody came along and put a margin of error on here of size epsilon, which could be any number they want. Okay, so I'm just going to put a margin of error on there of size epsilon. Okay, here's what I have to figure out. I have to figure out what is the corresponding margin of error on the x-axis so that if the x values are in this range, then the y values will stay within this range. In other words, how close to 2 would x need to be? That's the number I'm looking for. And that's going to be the number delta. Okay? And I have to find that number. How far can I deviate from the number 2 so that the y value will fall within my margin of error from the number -4? Okay, so let's do our scratch work first. Okay, let's write down what we want to happen and then figure out what we need to have. So we want the distance between x squared minus 4x and -4 to be less than epsilon. And we're going to work our way backwards to find out how big does this need to be. The distance between x and 2 needs to be less than what? Start with what we want, work our way backwards to figure out what we need. Okay? And sometimes it's difficult, but a lot of times it's not. So let's just work our way backwards. Let's start by simplifying. Okay, what's x squared minus 4x minus a -4? Isn't that going to be x squared minus 4x plus 4? So that's what I have in that absolute value, and I want that to be less than epsilon. Okay, do you recognize x squared minus 4x plus 4? Isn't that just x minus 2 squared? And we're wanting that to be less than epsilon. So the absolute value of x minus 2 squared, that's the same thing as the absolute value of x minus 2 squared. I want that to be less than epsilon. So how big does the absolute value of x minus 2 need to be? It needs to be less than, I should have said how small does it need to be. It needs to be less than what? The square root of epsilon. You see that? That's our delta right there. If the distance between x and 2 is less than the square root of epsilon, then the distance between our f of x and -4 will be less than epsilon. Okay? So this number delta there is the square root of epsilon. And if x is within that range, then f of x will be in this range. Okay? So now let's just write that out as a coherent argument. So we write, let epsilon be greater than 0. Suppose delta equals, what did we find for our delta that we want in this problem? We found the square root of epsilon. Okay. Then, for any real number x, comma, if the distance between x and 2 is between 0 and delta, then the distance between f of x and -4 will be, it will be what? It will be less than epsilon. But again, I don't want to just state that. I need to show that. So that equals the absolute value of x squared minus 4x plus 4, which equals the absolute value of x minus 2 squared, which equals the absolute value of x minus 2 squared. And if the absolute value of x minus 2 is less than delta, then the absolute value of x minus 2 squared will be, will be less than delta squared. And what's our delta? The square root of epsilon. What's the square root of epsilon squared? It is epsilon. Okay, so if the distance between x and 2 is between 0 and delta, then the distance between f of x and -4 will be less than epsilon. Okay? This might be very different than what you're used to in a math class. This is much more abstract and not computational. This throws some people for a loop. It throws a lot of people for a loop. So if you feel thrown for a loop, you're in good company, okay? So is every other person when they take Calc 1 and they get to this point. Okay? Now, let me say a few words about the examples and the problems that are in the textbook in section 1.2, okay? These problems can be straightforward or quite a bit more difficult, depending, okay? And I think that the best thing to do in a Calculus 1 class is to stick with the straightforward problems. So here's would be my suggestion when you read the book. Read thoroughly examples 2 and 3. Those are the types of problems I would like you to be able to do. 2 and 3 examples, okay? And in the exercises at the end of section 1.2, you should be able to do, I would say, problems 7, 8, and 9, and problem 12. Okay, the other ones, like problems 10 and 11, those are of a difficulty level that's higher than what I would expect from you, okay? 13 and 14 are actually easier, but it's one of those situations where because they're particularly easy, you do them slightly differently, and that tends to confuse people, so I'm going to wait off on those. Okay, so I would suggest you read section 1.2 and pay particular attention, read thoroughly examples 2 and 3, and for practice, try exercise problems 7, 8, 9, and what was the other one? 12. Okay? All right, that's it for today.